Good morning. If you looked at the program earlier today, then you might have noticed that I wasn't on it. Actually, one of our speakers has fallen ill, quite seriously ill, and so I just happened to have a talk available, and I'm filling the gap. But I just sort of want to put this idea to rest forever. I didn't organize this conference just so that I had an opportunity to speak. Oops, that's not entirely what I wanted. Cool. So what I'm wanting to talk about is how can I answer this question? Like, how can I be more productive and also have more fun in the process? Because I find that when I'm doing things and I'm being productive, I'm having a lot more fun. And I'm going to tell you about 4 ways that I do this. And of course, there are many other ways. These are the ones that I use routinely. So the first one, configure in the head. What do I mean by this? Well, let's just consider for a moment what my typical script looks like. Right at the top, I load a bunch of libraries, then I load some data. Then I prepare the data, and I do an analysis, build some models, maybe make some predictions. And then I store those results, so I disseminate them, send some emails, and then finally, maybe I close up and close database connections, and I'm done. But in the process, that script probably has a whole bunch of configuration variables sort of kind of scattered willy-nilly across it. And it may look something like this. So for example, right at the top of the script, I might define a debug flag, and then I have a chunk of code, and then I have a couple of other parameters, and then more code, and then like who I send my reports to, and then right down at the bottom, like the really naughty stuff, my how to log into the SMTP server. This is not ideal. And in fact, I think that this is like the Jackson Pollock approach to writing code. Right? You scatter your configuration variables across the script in much the same way as he just spatters the canvas with paint. So what I'm proposing is a better way to do these things is that all of your configuration variables go at the top. I mean, in actual fact, if you think about it, it completely makes sense. You open your script, and at the top of the file is all of the configuration details, and then you kick off with the rest of your script below that. Of course, I still have this issue of these naughty authentication details embedded in my script, which is not cool at all. So there's a better way of dealing with those, and that is you actually you put those in the environment, right? They're not actually there in plain text, and then you use sys.getEnv to source that information from the environment. And you can do that for your configuration variables as well as anything else like debug as well. That can also be picked up from the environment. And that definitely makes things simpler, as we'll see in a little while. Okay, I know, anathema, right? Burn this heretic. How can I possibly be suggesting that we ditch RStudio? I say this with jest, right? So, I mean, by all means, use RStudio, but sometimes it's not the right tool for the job. And there are other ways to do things more efficiently. And in actual fact, there was other stuff before there was RStudio. You know, let's look at the timeline. R was released in 1995. RStudio came along in 2011. So, I mean, we had a much longer period of time without RStudio. That was when I started, like way pre-RStudio, and I picked up a couple of things in the process. The one is how we can run things efficiently in the terminal, and there are 2 approaches to doing that. The one is you can use RScript, and this actually allows you to write basically an executable chunk of code. So at the top of your script, you have this a line that basically tells the shell that it should take the content of the script and pipe it into RScript, and it's hence going to be interpreted by the R interpreter. And then on a Linux machine, at least, you would take that script, you'd make it executable, and that would mean that that script can then just be run like any other executable, which is quite handy. So typically, you would use this if you're wanting to have a standalone script, or one where you're going to be picking up all of your configuration from the environment. The other approach is to just use the command line version of R, and in this instance, you would have a script without that particular first line, and you would just pipe the contents of that script directly into R. What situations would you use this in? Well, for a start, if you have a script like this and open it in RStudio will still interpret it as an R file, whereas the .sh file here, you won't get all your nice color formatting going on. Okay, so moving on to now how we can do some flexible configuration. Well, revisiting the hello world script that we saw before, but now actually breaking it out into a variable for name and then executing message hello world by default. We can, if we just pipe that directly into R, we get the expected result hello world, but we can now change the name by using a little bit of shell magic. One of the standard Unix command line tools is sed, and it basically allows, it's a stream editor, allows you to make string substitutions. So substituting for world users, and then piping the results through R, and now we get hello users. How can we do this from the environment? Well, again, our hello world code, and here we're getting name from the environment, and providing a world if there's no name defined in the environment. So without anything special, we get hello world. If we define name in the environment, then we get hello users. Okay, so let's look at something a little bit more concrete. Bucklands needle is an experiment that goes back to the 19th century. The idea is that you have strips of colored tiles on the floor, and you drop a needle on those, and then you look at the probability with which the needle falls on an interface between the two colors. And you can use that probability to then go and calculate pi, which is kind of nice. So I have a script for that, and at the top of that script are some configuration options, the most important of which is the ratio, which is the ratio of the length of the needle to the separation of these colored strips. And by using that same bit of shell magic, what I can do is I can substitute for a ratio of 0.75, a ratio of 0.25, right? And what I can then do is build up a script that does this for a whole bunch of different values of that ratio. So I can run a whole series of different configurations of the same problem. Right, now, I understand that you could do this within R by doing that bad thing, writing a for loop. But this is quite nice because you just write one script and then you change the configuration of that script externally. Yes, you can. Okay, point number 4, use the cloud. Okay, so this is my wish list. And I'm a simple man, so my wish list has 2 items on it. Item number 1, world peace, because world peace, obviously. And then item number 2 is I want a massive chunk of iron, right? Something that is truly astronomical, but I'm going to take it up another level, and I only want this thing for half an hour. And in addition to that, I have a budget of $15. Right, so I'm asking quite a lot on point 2. Point 1 is easily achievable. So what I'm really aiming for is this, but I have a budget for that. Okay, but fortunately, thanks to like Amazon and some other people, it's perfectly possible to get what you want for like a reasonable price. If you look at these 2 machines here, machine 1 CPU and 1 gig of RAM for 1/3 of a cent per hour, and something pretty big for $26 an hour. So I reckon I can definitely have the machine that I'm after at the right price. So I have a demo, which is on YouTube because I am far too cowardly to actually do this live. So I'm going to just talk you through it. So this is what the dashboard on AWS looks like, and basically you have 2 options. You can either launch an on-demand instance or a spot instance. The spot instances are much more affordable, so that's the way I'm going to go. The first choice you need to make is, right, what kind of an image do you want to install? And I'm going to pop onto that an Ubuntu 16.04. The next choice is, right, what kind of machine are you going to deploy that image on? And you'll see that there's a very wide choice. For me, price is the highest priority, so I sort according to price, but I still want a decent machine. It's not going to be that 128 CPU one, though. So I'm going for something in the order of 8 CPUs, and I'm going for the T2 2X large, which gives me 8 CPUs and 32 gigs of RAM. Select that, You scroll a little bit further down, there are a bunch of different options, but for the majority of them, you can just accept the default. Probably one of the most important things you need to do is set up security groups, and here I'm selecting my SSH one, so I can actually connect to this remote machine. I've got a key pair that I set up before, right? That enables me to authenticate onto the machine. I launch the instance and go back to the dashboard, and I'm going to go and have a look at my list of instances, and what you'll see is that the instance that I've just created is currently being provisioned. So basically, AWS is spinning up a virtual machine for me. They're installing Ubuntu. And key thing to get here is your DNS entry for that machine. So copy that onto the clipboard, flip across into a terminal, and then make an SSH connection to your Ubuntu machine, just copying in that DNS entry that I just got from the dashboard. And within moments, you're actually operating remotely on this 8 CPU machine. Now, it's a terminal, so I like to have some options. I launched tmux, which allows me to have multiple windows in my terminal. So now I have 2 windows. I'm going to be doing things in both windows at the same time. The first thing that I need is to install R, right? And to get that working, I'm going to update the package repository, so apt update, and then I install rbase as well as htop. Htop, you're going to see in a moment, will allow us to see how many processes are running across the machine and to what degree they're utilizing the CPUs. And then I go and I grab my code for Bucklands Needle. I'm just downloading that with a tool called wget. Oh, incidentally, you'll notice that the bandwidth on AWS is absolutely phenomenal. So if you have anything that's bandwidth dependent, you definitely should run it on AWS. So that's what my script looks like, and you can see that those are the default parameters that we saw before in the presentation. And I'm going to be looking at ways of running this script with different combinations of those parameters. Using sed, I'm making a simple substitution, 0.75, replacing it with 0.5, but now, because the window is relatively small, that's all disappeared off the top of the window. So I use head to just give me the first 10 lines. And you can see that the 0.75 has been replaced by 0.5. That's the original, and that's with the substitution. Right? So now I want to run that code with the different parameters. So I pipe it into R and launch it. And the result comes back. Well, it's running 500,000 iterations. The result comes back with something pretty close to pi. Popping over into the other window, I'm now launching htop, and these 8 bars at the top there give you the indication of the CPU utilization. So just launching the same job again, you would have noticed that I got 100% utilization on one of those CPUs. Right? Ultimately, I want all those CPUs operating in parallel. What I'm going to do for starters is run 4 jobs, but do that serially. So I'm going to look at 4 different values of the ratio and run them. And what you'll see is that it's always running on just a single CPU. Like each of these serial jobs is only utilizing one portion of the machine. So this is not ideal. I want to utilize everything. So what I'm going to do is launch now 8 jobs, and each of those jobs is going to be popped into the background as I launch it. So with some more shell code, basically just a for loop in the shell, putting an ampersand at the end launches these things in background. And what you see is that they're all being launched in the background, complete utilization of the entire machine, and all 8 of those results appear almost instantaneously, which is super sweet. Right, and then I'm done, right? So, like, I know exactly what pi is now. In fact, I have 8 estimates of pi. And so I exit the machine. Importantly, I go back to the dashboard and shut this down. Because, in principle, you could be being billed $26 an hour. If you leave it running and you go back to AWS like a week later with a sad story, they won't want to know your story. And that's it, you're done. So I know that this is like a synthetic example, but the idea is that you wouldn't be running Bucklands Needle, you'd be running something a little bit more sophisticated. And yeah, that's what I have to say. Thank you very much.
Okay, thank you very much. Questions?
Nick?
What's the biggest machine you've ever run on AWS?
I've run a 16 CPU machine.
16?
Yes. So, I mean, I'm looking for a problem where I can really justify launching that massive machine. Do you have one?
I've run the 64 CPU.
Okay.
But that's for bigger data work. But it's all the same.
Yeah.
Anyone else?
Robert.
In your video, it seems like your estimate of pi is pathologically always under. And you've got an NA in there that you quickly moved away. What happened with your R script? Because I feel like if you had an IDE to debug it, you're running a better code.
So Robert raises a very good point, and I will completely confess that I did not spend an awful lot of time, making sure that I got good values for pi. The nan is because that was for a needle of length 0, and you're not, that's not going to, at no stage is that actually going to be sitting on the gap. What?
So I noticed you use satRday to subsidy something. I was wondering how is there a reason you might not use a command line card or something like in other languages you might use that, right? Is that not so?
I suppose there are many approaches, but I mean, I use sed routinely, so it's kind of my tool of choice, and it's very lightweight and very flexible because you can make that substitution using a regular expression. So you can basically target precisely what you're aiming at. Jason.
How much did it cost to run that demo?
Oh, well, that was like maybe 5 minutes at $0.01 an hour or 5 cents an hour. It was super cheap.
Do they charge you per half hour? Or?
No, it's literally per second online.
Cool, thanks.
Yeah. It's very cost effective.
Okay, no other questions? We have a little bit of time if there are any other questions. So feel free.
Sure, and Azure as well. So basically, and DigitalOcean, there are a bunch of different cloud platforms where you can launch an instance. Yeah.
Cool. My question is, so when you're running in parallel, firing up multiple R instances, and have you ever had an issue where you written or read from the same resource that was contention?
I suppose that could arise. It certainly might well arise, but I mean that would be, I guess, more of a problem if you were writing results to the same instance rather than reading from the same. Yeah, that was definitely something. If you're running separate instances of R, that's certainly something that you'd have to take account of. Maybe writing your data to a database would be a better approach in that case. So you could have SQLite installed and do precisely that. Yep. Open your connection, write, close your connection.
Thank you. I've never used one of the cloud services before. Are you able to set up a computer that you can then access again? Can you set up a setup that you can access again, not have to install R every time you use it?
Oh yeah, for sure. So you can create an image with all your stuff on it, and you can store that. But I think you pay for storing that. But I mean, a different approach to that would be to make a Docker image with all the stuff you want, and then simply instantiate that image in the cloud.
We'll answer the